We're about to begin one of the most important units in the class, inheritance and polymorphism. These are two of the most powerful ideas in object-oriented programming, and they enable all kinds of reuse of code, which saves us work and is just good design. We'll start, though, by discussing class variables, so that's static variables and methods, which we've seen before, but now we'll review just really quickly. So far, mostly what we've discussed have been instance variables and methods. Okay, an instance variable belongs to an object, and it gets storage as soon as the object is created. Every object has its own set of instance variables, and an instance method gets activated when we call it by sending a message to the object. Okay, you can see the syntax for that is right here, right? The object name and then the method name itself. But in Java, we can also use class variables and methods. And a class variable, just like it sounds, belongs to a class. Its storage gets allocated as soon as the program runs, and it's independent of any specific instance of the class. We don't have to actually make an instance of the class in order to use a class variable or method. A class method gets called when we send a message to the name of that class. You can see the syntax here for that, class name dot method name. That's different from the way we would call an instance method, where we would do it using the name of a specific object, a specific instance of the class. Now, we use the word static, the keyword static, to designate a class variable or a class method. So let's make some modifications to the student class so we can see how this will work. Suppose we wanted to count all the student objects initiated during the run of a program. Okay, so to do this, we can introduce a variable which we'll call student count. And this variable gets incremented in the constructor every time a student object gets instantiated. Okay, so because the variable is independent of any particular student object, it has to be a class variable, a static variable. Now, on top of that, we need one method to access the student count variable. It's our getter for it. Now, that returns the variable's value whenever we want it. Now, because getStudentCount doesn't manipulate any particular student object or any particular student's object's information or data, we also make this a static method, a class method. We'll discuss some changes that we'll make to add the class variable and the class method to student. Now, we're going to add it to the end of the class template after everything else. There's no rule that says it has to go there, but it works just fine, and it as well as any other location. And so it's our convention that we'll use. So you can see everything in the student class looks the way we expect. We'll have all the same instance variables, all the same constructors and instance methods. That's fine. What we add here at the bottom is a static variable student count, which is an int. And notice this also has a visibility modifier, private, public, protected. So in this case, it's private. And it also has the getter that we talked about just a second ago. Notice how in the student constructor, we actually increment student count. We increment that static variable. That's how we actually get the running count of student objects that have been created. Here's how we might use the student class. You can see we instantiate several student objects, S1, S2, and S3. And then finally, we can call this static method getStudentCount using the name of the class. And this code will print out 3. Because student count, every time we've called this constructor, it's been incremented. So at this point in the code, if we call this method, it prints out 3. If we had done it here, it would have printed out 2. So again, make sure you notice, class messages, class methods are called by using the class name, in this case student, not any particular object, not any particular instance of the class. You should also note that we don't actually try to manipulate the student count variable directly. Because we really want to hide that information. We want to control how student count itself gets modified. And so we force ourselves to only do it in the ways we want. Okay, it only happens in the constructor, and we can only access it through the getter that we wrote. So in general, we want to use a static variable in any situation where all the instances share one common data value, one common piece of information. And then we want to use static methods to provide access to that information, like getters, static getters. Now, if we were to use final along with static, what we'd end up with is a class constant. Okay, a class constant gets assigned as soon as the variable is declared, and it can never be changed afterward, at least in that run of the program. So what we can do to see how this works is actually modify the student class one more time by adding two class constants, min score and max score. And we'll use these constants in the method setScore so that we can hold the score on any particular test between the min and the max scores possible. Say that's 0 and 100. Now, normally class constants, we've seen this before, we like to capitalize them and separate the words using underscores. That's different from the way we typically style regular variable names, but we've seen that before. So here's a further modification of the student class, assuming we have everything else that we had before. Well, look, what we're saying is now I'm going to add two static constants, public static final int, min score, that'll be 0, max score will be 100. And now in setScore, we're going to make sure that despite whatever input we get as the score to set the particular test to, we'll make sure that it doesn't exceed the min score or the max score on either end. Okay, we're going to cap it at the max score and make sure it's above the min score. Okay, the method max here returns the maximum of the two parameters, and min returns the minimum. So an example of how we might use this, right? If I make a new student object called S, I try to set its score to -20 or to 150. Well, hey, both of those are actually outside the possible range from 0 to 100. So we'll end up getting min score here and max score here, and 55 works just fine. That's within the bounds that we set. Okay, so then if I print the student object, well, the way the toString method is defined, it's going to print 0, 155, 0 being min score, 100 being max score, 55 being the one that worked. And if I print the class constants themselves, which again, I made public actually. These are made public, so I didn't actually have to make a getter for them. I can do student.minscore, student.maxscore. Okay, there's two simple rules to remember when you're using static variables. First thing is, class methods can reference only static variables and never an instance variable. And that makes sense because a static method doesn't rely on any one particular instance of the class existing. If there is no instance of the class, you haven't made a particular student object, then if you have a static method, it doesn't make sense for that static method to be referring to an instance that might not exist. Second rule is instance methods can refer to both static and instance variables. Okay, so I guess the key thing here is static information, static data, static variables and methods exist right from when the code is compiled and don't rely on us making any new instances of the class. Now, if you think back, all the methods and variables in the math class that we've been using, they're all static. That's why we're able to use them as math.max or math.min, or in the case of pi, as a static constant, math.pi. So we've been seeing this for a while now, and in fact, we've even addressed this topic before, but here we have it once again. In fact, the most famous static method is main. The fact that main is static means that we can call it even without having created an instance of whatever class you're writing, whatever class it's in. Okay, so before you close up shop here, the big ideas you want to be familiar with. You want to be able to define a static constant for, let's say, something like the default number of test scores in the student class. Think about how Java allocates memory for instance variables versus static variables. When does that happen in the running of a program for instance variables versus static variables? And think about what the error in this code is and why there's a mistake. Okay, what could we do to fix it? That's it for today.